7, 6, 5, and 3, 2, 1. Okay. And then here, once again, we don't want to multiply. We want to cancel before we do any multiplication. And so we notice that on the bottom, 3 and 2 cancel out with a 6. And so we're just left with 35. Okay. This is how you do it in real life. Nobody actually multiplies the whole factorial. Okay, so here's basically the trick. We look at the number on the bottom, so that's the 3, and then we write out that number of factors from 7 factorial. Makes sense? So because we have 3 on the bottom, we're going to write the first 3 factors from 7 factorial. That's 7, 6, and 5. And then on the bottom, we'll have 3 factorial. So 3, 2, 1. So it's 7, 6, 5 over 3, 2, 1. And then you do the canceling, whatever. Cancel as many terms as possible, and then you'll have your final answer. Make sense?
So the first 3 factors and all the factors of 3. Is that correct?
What?
So if it was 4, the equation will be 7, 6, 5, 4 over 4,
Yep.
2, 1.
Yep. Let me do another example, just to illustrate this point. Let's do a large one. Let's do 11 choose 4. Okay, so 11 factorial, even I don't have that memorized. Okay, so I'm not going to do that. But if you do the trick that I just showed you, so the bottom number is 4. So we're going to take the first 4 numbers from 11 factorial. That's 11, 10, 9, and 8. And then on the bottom, we write 4 factorial, which is 4, 3, 2, and I'm just not going to write the 1 because there's no point in that. Make sense? So 11, 10, 9, 8 over 4, 3, 2. And then I try to cancel as much as possible. So I see that the 4 and 2, they cancel with the 8, right? And then the 3 canceled with the 9 and leaves me a 3. And so the final answer is 330. Okay? That's how you can do these binomials in your head, which is quite important. Yeah, Alexandra.
In the other one that we did with 7, in grade, you listed everything out for 7 factorial and then canceled it out. But why did you not include 7, 6, and 5 for 11?
Well, it's just the trick I'm showing you guys, right? So everything 7 and below is all canceled out with the 7 factorial. Because this is really 11 factorial over 4 factorial times 7 factorial. 7, 6, 5, 4, 3, 2, 1, that's all canceled out by this. So that's why I'm not writing it. Yeah. Okay, let me also show you guys something else quite important.
What about?
Huh? Jaden?
Can you do one with the 0 at the bottom?
Sure, I'll get to that soon, yeah. Let me show you guys something first. Suppose we had 11 choose 7, okay? Now this one's harder because we have to write out 7 of the first factors from 11 factorial, right? So that's 11, 10, 9, 8, 7, 6, 5 over 7, 6, 5, 4, 3, 2, right? Now this is starting to get annoying because we're going to have to cancel out so many factors. And so here, you have to use another trick, which is that 11 choose 7 is actually equal to 11 choose 4. So this is the identity you should memorize. N choose k is always equal to n choose n minus k. So you can always convert it into an easier binomial. So 11 choose 7, you can convert to 11 choose 4. 10 choose 9, for example, on the 1e, you can convert to 10 choose 1. Okay, that way you don't have to write out so many factors. You can convert it to the easier version. Make sense?
So, Mr. Nine, you're writing out these numbers, these factors with no parentheses or anything. Is that proper notation? Or
No, it's not, but when you do a lot of this...
Would you take it and put it on a...
Yeah, if it's just your work, it's fine. If it's your answer, that would not be okay. Yeah. Okay, any questions? Let me go to Jaden's point. So here's something important you should know. 1 factorial equals what? 1. How about 0 factorial?
0.
No, equals 1. Okay?
Wait, how?
It's defined like that. So you have to use the fact that n minus 1 factorial equals n factorial divided by n, right? Therefore, 0 factorial equals 1 factorial over 1, which is 1. But you don't need to memorize that. Just remember 0 factorial is 1. That's just how we define it.
So then can you do A, 0 parentheses?
Yes, you can.
Wait, no, can you do it?
Yes. Okay, so anytime we have n choose 1, this always equals n. And whenever we have n choose 0, this always equals 1.
Oh,
You should just memorize that. Right? The reason is because n choose 0 is equal to n factorial over 0 factorial times n factorial, which is 1, right? So that's how we get that. So I would have these memorized just for convenience. Anything choose 0 is always 1, and anything choose 1 is always itself. All right, I think you guys can probably do first A through G.
Check my answers, please.
I think 9 choose 4 is wrong. I think
Which one?
9 choose 4.
9 choose
I
this
think
one?
that's 54.
Yeah.
Seems too small.
Wait, let me double check it. Let me
Does
think.
this like work?
7. 976 432. Yeah, I think 54 is wrong.
Does this work? Does this work?
Where's your denominator for all of
Yeah,
these?
because that's what I'm saying. So, if you can cancel out like 8, 7, 6, 5, 4, 3, 2, 1 on both sides, because these are really big, right? But it doesn't work. It doesn't work for like stuff like this though.
Yeah, all of these are wrong.
All of these are wrong.
Yeah.
Wait, even this one's wrong.
Yeah.
Why?
You're not using
Is
the
my
formula.
wait? Is my logic not logicking?
Your formula, you're not using the formula at all.
Not even here.
None of these.
What?
Because it's 6, 5, 4, 3, 1, that's fine in the numerator, but the denominator is 4 factorial times 2 factorial. Right?
Where's 4?
You have 2 factorials in the denominator.
What do I do with? What's 4? What do you mean by? Wait, what? Where do you get 4 factorial?
N minus k?
7, 6 over 4.
What does K stand for?
2. This is k. 2 is k. Okay, you need to use the trick that I told you about. Oh, thank you.
Or is it 108? So I think I made a mistake here. Or I did 324 over 6.
Because 6. Because 6, 5, 4, look.
108, no.
No, no?
No.
What?
These cancel out. This is 1.
This is wrong. That's it, I think.
No, you're doing it right. I said I'm just.
Well, honestly, you don't even gotta go that. Like, in theory, just. So, since it's 6 over 2, you only have to do the first two terms of 6 factorial. So that'd be 6.
I don't know. I mean, your steps look generally right. I think you just miscanceled it. Yeah.
Wait, why did you include 4, 3?
Good.
That right too.
because the rest of them would cancel out. So if you write all of them out, so say for 9, 9 choose 4. If you write out 9 times 8 times
Your formula.
5
Yep.
4 times 3
And how it's supposed to help us solve like the really long intervals.
Sure.
It's like these two, I think. Maybe you can use it.
You can use it for all of them.
Alright, these 3.
Yeah, so my trick, you don't need to write out the whole factorial at all. You see it's always canceling out, right? So for example, here, I'm only going to write 9876 because I'm looking at the number on the bottom, and I choose that many numbers to write in the
Basically
factorial.
just writing it up to 3.
Not including 3. Up to, but not including 3.
It's like writing
Here,
up to 4.
but here, I would choose 11, choose 3. I'm going to convert this to 11, choose 3 because it's faster to do. Then if I convert that to 11, choose 3, that lets me write 11, 10, 9 over 3, 2, 1.
Okay, so can't I just cancel it over like that?
Sure, but why would you want to write 10 numbers?
But what if I just wrote like this on my paper? Would you understand?
That's my point, right? That's what you should be writing to save time.
Oh,
Yeah.
okay.
Was it 126?
Mm-hmm.
Okay, thank you.
A is right. This is not 42 though.
Oh shoot, wait, sorry, I didn't.
Yeah, you should use my trick, not what you're doing. So instead of multiplying out the whole thing in the numerator, you should cancel as much as possible first. So these 3 and 2, that obviously cancel with a 6, right?
Shoot, right.
Yeah. So everything will always cancel. You'll always find something to cancel. Yeah.
Why did you, like, why did you write out for like 4 through?
What?
Like, why did we write out, like, for this, aren't you supposed to write out to like 4 through?
Yeah, that's the point of my trick. Because I know it's going to cancel. So I don't even write it, right?
You know it's gonna cancel that. Or like, what?
Right, see, what you're doing, you're doing this, you're writing out the whole formula, which is good, but you see how 1 factorial always cancels out completely with the numerator? This 4 through 2, that goes completely, because there's 4 through 2 here. This 4 through 2, it's gone, right? So my trick is, you just look at the number on the bottom, which is a 3, and you write that many numbers from 7 factorial, and you just stop there. Because everything else will cancel, right?
Just search it up, I don't know.
You're not going to find my trick online, but... this is wrong. That's it. The other ones are right.
I'm Mr. Nye. We got like different answers for like. So this is when I.
Yeah, they're both... Oh, F is wrong. Like, where's the numerator, right? Shouldn't you have a 3 factorial on the bottom?
Why would I have 3 factorial? Oh, because
You're converting this to 11, choose 3, right?
yeah.
So there would be a 3 factorial on the bottom?
Okay, so then I cancel the 3 factorial and I get 11 times 10 times 9 times 8, 7, 6, 5, and then 4. And then I multiply on that.
Well,
You only do this first
my point is you should rewrite 11, choose 3 into 11, 11, choose 8 should become 11, choose 3.
Okay, so
That makes
then
it
you write the
easier.
first 3.
And then I'm going to write the first 3, right? 11,
Yeah.
10,
Okay.
9 over 3, 2, 1.
You only take the first. Why
Yeah, I'll explain.
That's what you did. That's what you did earlier, isn't it?
No, I just like.
Okay. Well,
Okay, I will.
Okay, we got this. We got
I'll figure it out.
mhm.
Just missing like half of these words. Each type.
It's good. Oh, D is wrong.
Yeah, it's not.
You put yourself in the word problem.
Yeah. Just to prove to you guys that I write them myself.
So you hired your problem writer to say Mr. Nine your problems?
Do I have money to hire somebody to do that? Yes.
Question on like how do you do this formula? Like do you when you find like k, you just minus it, but then do you still add k's? I'm like really confused with that.
The formula, all I'm doing is converting this into an easier one to do with my trick.
Like
Right.
how? Like do you first you find k and then you minus it from 8? Do you still include
No,
k?
so
like,
k is 8.
Okay, k is 8.
And so I rewrite this to 11 choose 3. They're the same. So the formula tells me that these are equal to each other.
And then you just treat it as
Yeah, so now I'm going to calculate 11 choose 3, which is 11, 10, 9 over 3, 2, 1.
Yeah.
All right.
oh, so you just don't involve this whatsoever.
Yeah, because the point is this is harder to do with my trick, because this is
They're
11,
gonna
10,
cancel out
9,
anyway, so
8,
I
7,
think
6, 5, 4.
So the easiest thing,
All
just
over 8,
memorize
7,
this,
6, 5,
right?
4, 3,
Like
2.
how you said,
So I don't want to do
the
that whole
bottom
thing.
number's 4.
So it's easier to write it in this form.
9, 8, 7, 6. Because what you're doing is you're basically you're canceling out. It's kind of like cross, like you know how you multiply, like whatever. Well, if you do this, you like before you do this, you're like, oh, I can cancel it out too, cancel this out. It's like basically doing the same thing here. You're canceling out the numbers I would have canceled out anyway. So 976 over 4 through 2.
Okay, guys, let me show you guys one last example, just because you guys, some of you guys don't get it.
These are the same. So press that out.
Okay, please go back.
There's 2, and then you can 9 times 2 times 7.
Please.
That's it, yeah.
Let me show you guys another example, just to make sure you guys all get it.
And then some of them it's easier if you like.
Let's say we wanted to do 15 choose 11. Okay? So my first step, I'm going to use my formula, which tells me that 15 choose 11 is actually equal to 15 choose 4. Okay? Because 15 choose 11 is harder to do using my method. Okay? So 15 choose 4. I'm going to look at the number on the bottom, which is 4, and then I'm going to write down 4 numbers from 15 factorial. So that's 15, 14, 13, 12. Yeah? And then the bottom is going to be 4 factorial. 4, 3, 2. Okay, that's it. And then you just do all the canceling, right? So 4 and 3. 4 and 3 cancels with 12. 14 cancels with 2 gives me 7. And my answer is... yeah, whatever this is.
You doing it in your head, Mr. Knight?
Clearly not.
Yeah, that's definitely on the top.
I thought that was an 8.
My mental math is actually not very good. Yeah. I don't know what that means. Your question doesn't make sense. That's what I mean. Okay, are we finished? Are we finished with question 1? Let's start with question 2, binomial theorem. Binomial theorem. Did you guys learn this in algebra?
Yeah, I think so.
Pretty sure you guys did, so.
Oh, Pascal's triangle, right?
Kind of, but we're just not going to talk about Pascal's triangle today. Because that's not a practical way of calculating binomials, right? You have to write the whole triangle. Okay, so here's the binomial theorem. It basically tells us how we can expand x plus y to the nth power without having to, multiply it n times, which would be very annoying, wouldn't it? So binomial theorem tells us that this is equal to n choose 0 times x to the n y 0 plus n choose 1 x n minus 1 y 1 plus n choose 2 xn minus 2, y2,
What?
plus dot dot dot, dot dot dot, plus n choose n minus 2, x2, yn minus 2, plus n choose n minus 1, x1, yn minus 1, plus n choose n, x0, yn.
So what's the formula?
This is the formula. Okay, you're not supposed to memorize this. You're just supposed to look at the pattern and be able to reproduce this, right? So let me show you guys the pattern, right? Okay, so first let's look at the coefficients. The coefficients are always going to be binomials, right? So it starts from n choose 0, then n choose 1, n choose 2, dot dot dot, n choose n minus 2, and blah, 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 right? So the coefficients should make sense. And then let's look at the exponents of x. So the exponents of x, they start at n, right? Because we have a power of n here. So we start at n, then they incrementally decrease by 1 for every next term. So it goes from n to n minus 1, n minus 2, all the way to 2, 1, 0. Okay? And then y is just the same, except it's in reverse. It starts at 0, and then it goes up by 1 and all the way until we get to n. And that's it, right? Yes?
The, like, subtracting by 1, so n minus 1, n minus 2. So
Mhm.
what number do you go to?
You go all the way until you get to 0. All the way until the last term, where equals 0. Okay? And then y starts at 0 and goes all the way up to n. All right, so as long as you understand the format of each term, it's not very hard to memorize this formula. Okay, so just try to remember every term has 3 components. It has its binomial coefficient, it has a power of x, and a power of y. And the power of x and the power of y, they always add to n. So it'll be n and 0, n minus 1 and 1, n minus 2 and 2, etc. Any questions? I'll do an example. Suppose we had x plus y to the 4th power. Are we all listening?
Of course.
X plus y to the 4th power. So I'm going to start with 4 choose 0, because n is 4 here, right? So it's going to be 4 choose 0, and x we start with 4, and y starts with 0. So 4 choose 0, x4, y0, plus 4 choose 1, and then x will decrease by 1, and y will increase by 1. So x3, y1. You just keep going, right? 4 choose 2, y squared, x squared, y squared, plus 4 choose 3, x1, y3, plus 4 choose 4, x0, y4. All right, and if you simplify this, you get x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. Okay, so make sure you know how to calculate binomials quickly.
Wait, can you scroll up? I need to copy that.
Yeah.
Wait. We actually have to do this, like this whole process?
Yeah.
Wait, where'd you get the 6 from?
6 is 4 choose 2.
Oh.
So 4 choose 2 is 4, 3 over 2, 1, so that's 6.
We're doing row echelon forming? It's like row echelon.
It's quite a bit easier than that, so. Like, these problems are like 2 steps max, right? Row echelon, that was like 20, 30 steps. But you guys did the best on that test, so. Well, maybe because you guys got 23 points essentially on those questions. All right, let me do another one. Let me do another one. So sometimes you're not going to have it so straightforward. You might not always have x plus y. Suppose we had
X plus 1.
Wait, Mr. Nunn, how many times do you do it up till whatever n is?
yeah.
Okay.
So don't go below 0. Let's say we had x minus 2y cubed. okay? So this one's a little different, right? Because we don't have x plus y anymore. But we can think about, x is in the x position, and now we have a negative 2y in the y position. So we apply the same formula, except we replace y with negative 2y. Okay? And so I'm going to apply binomial theorem. N is 3, so I'm going to start with 3, choose 0. 3, choose 0. And then I'm going to have x3. And now instead of y, I'm going to have negative 2y to the 0. Because I'm adding, essentially, this term is a plus minus 2y, right? So y becomes negative 2y. Now just keep going. 3, choose 1 times x squared, negative 2y1, plus 3, choose 2 x1, negative 2y squared, plus 3, choose 3 x0, negative 2y cubed. Okay, so it's the same process. You just replace the y with what you have in that position. And then if you simplify this, you'll get x cubed minus 6x squared y plus 12xy squared minus 8y cubed. I think that's right. Any questions? Yes, Alexandra?
Problem 4, is it 6 or this one's because the 4 factorial
4 choose 2 is 6.
Wait, how is 4, 3, 2, 1 over 2, 1?
It's 4, 3, 2. It's 4, 3 over 2, 1.
How do you get minus 8y to cube? How do you get 8 from there?
Minus 8 is negative 2 cubed. And 3 choose 3 is 1.
It's just 1?
Yeah. Right, 3 choose 3 is equal to 3 choose 0, which is 1.
Okay. What about 3 choose 2?
3 choose 2 is equal to 3 choose 1, which is 3. Yeah, Alexandra.
I don't get the 4 choose 2 part.
4 choose 2 is equal to 4 factorial over 2 factorial 2 factorial. Right, if you use my trick, it would be 4, 3 over 2, 1. I automatically skip this step. Well, my 1A all finished it, so you guys should be fine.
Is there a shortcut for this one?
Yeah, do it in your head.
Oh,
But we do it in.
Let's just say I'm not confident in myself, my ability to do this in my head, so I wouldn't do it in your head. Because it's very hard to keep track of the, the right binomial, the right exponent, the right sign. So I always write it out.
if I can do it in my head, can I write a guest article on the JP9 blog?
No, I don't take guest articles.
Once I make it on the JP9 blog,
You're not going to make it, don't worry.
I think you can. I believe in you. You got this.
Who's that guy in in the picture on the reflections on mathematics and geology? That guy.
I think it's a painting of David. That's why I searched up.
David? Wait. I think that's mathematics and God in scripture.
Oh, that guy. That's Paul Dirac.
Paul who?
Paul Dirac,
Direct.
Dirac, the physicist.
Is he a theologian too?
He's an atheist. If you read the article, you would know who he was.
Well, I mean, I read it.
Yeah. Okay, are we all finished? Just kidding. I'm just kidding. That was a joke. Let me know if you have any questions. I remember 2D is very tedious.
Wait, did Dirac talk about having beautiful equations?
Yes, he did.
I know how to expand it, but how do you?
And then you will put it by this.
So by this whole thing.
What's like the most beautiful equation to you, Mr. Nye?
Euler's identity.
Can you check the first two for me, please?
Oh, right.
I'm missing a 1,
Oh, so it'd just be +1 at the end.
right? Because you're missing a term of y to the 4th.
Oh, right.
Right.
Because I thought it was just
Same
0.
here.
So this is also +1.
Right? You're missing this term, right? This is 1 times y to the 5th. Because 5 choose 5 is 1. And x to the 0 is 1.
Wait, wouldn't it just be y to the 5th?
Oh yeah, you have it, sorry.
Oh, okay.
Yeah, I did see
But
it.
then, so this one would just be +1.
Yeah, so you're missing the 1.
Okay, okay. Thank you.
Wait, is it just like? Wait, I thought it was just like 2 times.
Oh, I thought we were doing it.
Oh my gosh.
Yeah. 2 A, B, C, D.
Yeah, I thought it was just 3 times 2.
Easy as A, B, 3, choose 1, 2, 3.
Yo, it's x to the 0.
When I was taking AP stats, our unit on counting and probability, that was the lowest average I've ever seen. It's like a 35-40% average on the test.
Wait, in English class, someone like had to write like a declaration
I can
about
explain it
something
later.
that they don't like and like change
Is
it,
this
and they
is
wrote
this
about
right?
it.
I did half of it in my head.
That makes really? Sense. Yeah.
Is that the first one?
What?
Wait, that's not right.
No. Your coefficients are wrong.
My coefficients are wrong. Dude, wait, I want to wait, okay.
Oh, wait.
Wait, what the heck?
Yep.
I think I understand how to expand it, but then multiply it.
Why for 1?
Can I use someone's eraser?
Choose 2.
Because it feel like this can be this divided by 2 times 2 minus 2.
No, 4.
Choose 2.
Oh wait, so I think it might be 1. Yeah, that's one. Just think about it. Think about it. 6 divided by 2 times 2 minus 2, so that's 0, and then 2 is 0. Oh my gosh. Okay. Read the room, bro.
Yes.
Read the room. Read the room. Bro, like imagine like if everyone was your son and I was like, damn it, Jay, this is like the easiest math that I've ever done in my whole entire life, bro. Come on, I do that. Oh, I don't. I only do that when it's like 3 divided by 2 times 4 divided by 2. Divided by 2, divided by 2.
Choose 2.
First line is good. Second line is wrong.
Yeah, right?
So for example, 5 choose 1, x to the 4th, y 1. Where did the y go?
It's really funny. I was not a person.
Is it going to be multiplying these three numbers? 5 times x to the 4th times y. And the next one. 15 choose 2, 10 x to the 4th times y squared.
Because it's just supposed to get to equals. No, only until, so look, this, until this gets to 0, until this gets to 8.
No, I'm not saying you're Japanese.
Let's continue in 2 minutes.
Wait, could you go up to the formula again?
Yeah. Wait.
N minus 0.
Mr. 9.
Yes.
I'm going down a little bit. Power flow. Thank you.
Wait, what?
6, 2, sorry.
No, you're good. Okay, back. Oh wait, this is like completely wrong. No, the 2 thing.
Yeah.
Yeah, it's good.
Oh, nice. This one's
Good.
I picked 2 of them.
Why the right side for 2 edits?
Wait.
Yes?
Wait, is it right?
You just. Oh, this? No. This line is correct. You're just not calculating the things right. Right, 4 choose 1 is 4, not 24.
Wait, how's it 4?
Just think about how you did all these, right? 4 choose 1 is 4 divided by 1, so it's 4.
Good job.
You're getting Friday at 25. You just get cost better.
Wait, is this 12?
Mr. 9, can you check these problems?
You should not have fractions. These are binomials, right?
Wait.
4 choose 3 is 4.
4 choose 3 is what?
4?
Wait, I don't understand.
Right? 4 choose 3. How did you do these, right? 4 choose 3 equals 4 choose 1, which is equal to 4 over 1, which is 4. Alright, just apply the same logic you did here. Okay? You good?
So on the test, are you also going to be having multiple of these?
Yeah, these are
Or should we just do one? Because I feel like one is like
Just,
very sufficient.
go try it.
Actually, maybe all.
It's good.
Okay.
Okay, I have to continue. I must continue. Let's talk about simple permutations. Okay, don't worry about question 2. You'll have the homework to struggle with that. So, do you guys remember what the difference is between a permutation and a combination?
One possible.
No.
Infinite?
So, no. Permutations is when order does matter. So order matters. And combinations are when order doesn't matter. Okay. So for example, we have 28 students in this class, right? Suppose I'm trying to choose 3 students to rank as number 1 and number 2 and number 3 most favorite student, right? If I were to do that, that would be a permutation because the order matters, right? It's ranked. So it would be a permutation of 28 people, and I'm permuting 3 people. On the other hand, I could also say, oh, we have 28 students, and I want to choose 3 students to give chocolate to. That's a combination because order doesn't matter, right? I could choose any 3 students, and the particular order doesn't matter. So that's the difference between a permutation and combination. Okay, how do we do some simple permutation questions? I'll do 3A, and I'll also do 3D, and I'll also do 3E. Okay, so let's start with 3A. So I'm trying to choose a password for my iPhone, and it has to be 6 digits long. My iPhone password is actually my birthday, so anyways. So here's how you do permutations. You try to, for any problem with permutations, guys, please be quiet. You try to imagine a bunch of buckets that correspond to the question, and then you think about how many possibilities there are for each bucket, and then you just multiply all of them. This works for pretty much every question you'll encounter. Okay, so my password has 6 buckets, right? There are 6 positions for the digits. How many possibilities are there for the first bucket? 10, right? 0 to 9, 10 digits. Repetition is allowed for the password, right? So that means for the next one, I also have 10 choices, and so on for all 6 buckets. And so my total number of permutations is going to be 10 to the 6th. The reason I multiply is because every single bucket is independent, right?
Why do you have 6 buckets again?
Because it's a 6-digit password.
This is combination.
This is a permutation because order matters.
Right.
Okay? Suppose now that repetition was not allowed. It would be a little different, right? I would have 6 buckets once again. And how many choices do I have for the first digit? 10 once again. But if repetition is not allowed, I'm only going to have 9 for the second one, right? And then 8, and then 7, 6, 5. And so this is whatever this is equal to. I have no idea. Okay? Any questions?
10 exclamation mark over 4 exclamation mark.
Very good.
I'm gonna be smart too.
Any questions about that? Okay, let me do now question D. I was going to say something, but it escaped my mind. I don't know what it was. Hopefully it wasn't important. What was I going to say? I don't know. Okay, question D. I have 12 juniors in my Calc Honors class and 12 seniors, and I want the juniors to sit in the front and the seniors to sit in the back. So that is actually what I do. Because the seniors, they're second semester seniors right now, right? So I don't care about their grades.
Oh wow.
I do want them to get A's, yeah. Okay, so how many options are there for the first position? 12, right? Because I have 12 juniors to choose from to put in the front row. And then 11 for the next one, because there are 11 juniors left. 10, 9, 8, etc. Now if I go to the back row, how many choices are there for the first seat in the back row? Very good. 12 seniors now to choose from, right? And then 11 seniors, then 10 seniors, dot, dot, dot. So my final answer is going to be 12 factorial squared. Okay. Any questions?
Can I just read that as my answer?
Yeah. Okay, so my rule is if the final answer is below 1,000, it has to be simplified. If it's above 1,000, you can leave it in whatever form you want. Yes, so you can leave it like this.
What's 10 to the 6th?
A million?
No repeats because a person. No
Wait,
repeats
wait,
because
it
a
is not a
person
million.
gets to sit in 2 chairs
10
at
to the
once.
6th? It's not a million. No way.
I don't know what to say here.
Mr. 9.
Let me continue with question E. Very good, Luna. Yes, no repeats.
Mr. 9.
Question E.
No, it's not.
Okay, question E. I'm trying to come up with 7-digit numbers using only the digits 1 through 7 with repetition allowed. Out of all the possible numbers, how many are divisible by 5? So what does a number have to be if it's divisible by 5? It has to end with a 5 or 0, right? In this case, only 1 through 7, so it has to be a 5 in the end. So I have 7 buckets for my 7 digits. And then I'm going to always try to fill the one that's the most constrained. So I'm going to try to fill the last bucket. So I only have one choice for the last bucket, right?
2 actually.
No, it has to be 1 through 7, so it can only be 5.
Can't be a 0.
Can't be 0. So only 5 in the last one. And then I go back and fill my first ones. So how many choices for the first bucket? 7. Repetition is allowed. It could be allowed. So 1 through 7. So 7, 7, 7, 7, 7, 7. So 7 to the 6th. Any questions? I have 7 choices for every bucket because I can choose between 7 digits.
Okay.
Okay, now let me do part G. What's your question? The last one can only be 5, so there's one choice. Okay. Let me do question G now. Question G is the same, except now repetition is not allowed. So each digit can only be used once. Once again, I'm going to start by filling the last bucket, the last digit. Has to be 5 once again, so I only have one choice. Now my question is, how many choices do I have for the first digit?
7.
No.
3.
6. 6 choices because I can't use 5. Okay? So how many choices for the second digit? Now it's 5, right? And 5, 4, 3, 2, and then finally 1. And so the answer is actually 6 factorial.
Oh, it's called factorial.
Yeah. You can also just say it in a very excited manner. Okay, I have one last thing to talk about, which is casework. What is casework? Sometimes you need to split your question into different cases, and when you have cases, you calculate the number of possibilities for every case, and then you add all the cases together. So let's say, for example, I think formerly this was true. On the iPhone, you used to be able to choose between 4 digits and 6 digits for your password. I don't know if that's true. Let's say it's true. Okay, so I can choose any password, but it has to be between 4 and 6 digits. So it could be 4 digits, could be 5 digits, could be 6 digits. How many possible combinations would there be? Not combinations, permutations, right? The answer would be 10 to the 4th, plus 10 to the 5th, plus 10 to the 6th. The reason is because my first case is there 4 digits, in which case I would have 10 to the 4th possibilities. Or I could also have 5 digits as my second case, or 6 digits as my third case. So in total, there are 3 cases, and when you have cases, you have to add them up. So it's very challenging in these questions to know when to add and when to multiply sometimes. But just trust your gut. Yeah. When I was doing these questions for the first time when I was little, I was always confused. But after some time, you can figure it out.
Imagine how I feel.
He was 3.
Imagine.
Yeah, he's definitely 3 doing.